the function of the thyroid. TSH that released from the anterior pituitary gland, and the release of this hormone is in turn controlled by the TRH, or thyroid releasing hormone. What is the site of secretion of this hormone? Hypothalamus. Okay. So by the cooperation of these three organs, we have the actually regulated production of the thyroid hormone. The second part of today's session is immunoassay. Okay, when we say immunoassay, it means that all the time we have the interaction between antigen and antibody. So we have the immunoassay. It is a biochemical test, and most of the time it's actually suitable, especially for a small molecule. Okay, but also you can measure the concentration of large, but most of the time is has applicable for the small molecule. Okay, like antigens, and sometimes it depends on a procedure. You can measure the concentration of the antibodies. The molecule, by the definition, the molecule detected by this procedure known as an analyte. For example, in today's experiment, what is the analyte?
Molecule that used for experiment.
For today's experiment, according to this definition, the molecule that detected by the immunoassay is often referred as an analyte. So, for today's experiment, what is the analyte? Which molecule we are going to measure? T3. Okay? So T3 is today's analyte. Okay? And it's in many cases, sometimes this is a protein, sometimes it depends on the actually design of the procedure. Analyte can be present in any kind of sample: urine, semen, milk, okay, serum, plasma. All these actually liquids can regarded as a source of analyte. You are familiar with the structure of antibodies, okay? So I skip on this slide. And about the ELISA, okay? ELISA is the abbreviation of the enzyme linked immunosorbent assay. And I will describe what is the origin of this actually abbreviation. At first, I want to describe that immunoassay generally can be present in different forms. Direct ELISA, indirect ELISA, competitive and non-competitive. So, what does it mean? Consider, as I show you, we will have a microtiter plate, okay? We have several wells in the microtiter plate. Consider this gray plate as a well, okay? I want to show you what happened inside each well, okay? Consider this gray plate as a one well. Sometimes, when you buy a kit, this is the ELISA kit, okay? You buy from the company, okay? Sometimes the company coated the antigens on the well. When you, what does it mean coated? It means that when you immobilize the reagents inside the well, it is known as a coated, okay? It's immobilized inside the well. This is a solid phase, and we have an antigen. If you want to measure, for example, the formation of immune complex, after adding the antibodies, this immune complex form, and these antibodies actually bind to the tracer. Tracer sometimes is actually fluorophore, sometimes a chemiluminescence, okay? But now we have the enzyme as a tracer. Can we detect the combination of the antigen and antibodies? Is it simple or no? For example, inside the well, you have an antigen, okay? I want to mention that if you don't have any tracer, can we determine the formation of the antigen and antibodies? No. So we have to add a tracer to the actually immune complex. This is again enzyme. Okay, we add the enzyme. Actually, if we want to measure the formation of this immune complex, we should have a substrate, and this substrate should be chromogen. So by the alteration of the intensity of the color, you can determine is there any immune complex formation of immune complex or not. Okay, because this is an immune complex. Because the label directly bind to the immune complex, it is known as a direct ELISA. Clear? When we have when we bind the tracer directly to the immune complex, it is known as a direct. I want to show, for example, this is a well. At first, you add, for example, antibodies. You should block the empty site for non-specific, for prevent from the non-specific binding. And these are for example, this is the T3, for example, binding to the enzyme. We require some wash step. After wash step, you remove the unbound, okay? Because bounded antigens to the antibodies is important to us. And it is detectable. Is it detectable now? You have a formation of the antibodies with the enzyme. Is it detectable? No. You should add a substrate. And you require time to reaction of the substrate with the enzyme. And after adding the color, after adding the stopper, the color actually is now yellow. And in a spectrophotometer, what another type? It is an ELISA reader. Okay, I will compare the spectrophotometer in the ELISA reader. You can read the absorbance of your sample. Okay, about indirect. When we say indirect, what does it mean? At first, I want to actually interpret for yourself. How you can understand from this slide? This is the indirect ELISA. What is the difference between indirect and direct? Who can describe it? As you can see here, again, this is the immune complex. Where the tracer outside of the immune complex. Whenever the tracer, I mean enzyme, is actually completely apart from the immune complex, it is known as an indirect. So, in the indirect ELISA, this method is specific. Sometimes you want to measure the specific concentration of some antibodies, okay? In a serum sample, this method is very suitable. Okay, maybe I ask you, which of the following kind of ELISA is suitable for determining the specific antibody or titration of antibody? You should choose an indirect ELISA. As I mentioned, we have a tracer apart from the main immune complex. And this is another representation of antibodies. For example, this is a biotin, okay? You wash and remove unbounded, and now you add the enzyme. For example, sometimes enzyme bind to the antibodies and sometimes bind to the estradiol. Because the immune complex is these two molecules. Is there any tracer? No. We add a second molecule, so it's known as the indirect ELISA. Okay, about competitive ELISA. This is the principle of today's experiment. Okay, when we say competitive, what does it mean? Competitive.
Fighting for the same
There is a competition.
competition, yeah, for the same site.
At the same site, exactly. We have only one binding site. For example, this is the T3, okay, and tracer, okay. You have two solutions for today's experiment. To each of them, you added two solutions. One of them was for a standard. You have a standard. For sample, you added serum, okay. And what was the second solution? Second
Conjugate.
solution.
Conjugate.